Use required properties in components and delegates. Required properties are essential when you need to ensure that a component's property is set wherever it's created, guaranteeing that the QML component functions correctly. This approach is especially recommended for delegate types, as it verifies that necessary properties are provided without the need for defensive null checking. Required properties in delegates map directly to model roles, which can be used instead of unqualified context properties, preventing lookup issues. Let's build an example to demonstrate this. First, add a component called stricter label. In this setup, stricter label requires these properties to be set when it is created. Now, create a model that provides suitable roles for a view to map to these required properties. Next, add a list view that uses stricter label as its delegate and test model as its data model. Run the code, and you'll see how stricter label displays the text and color based on the required properties populated from the model. You can use required properties in any reusable QML component, not just delegates in a view. This ensures that an error is raised if properties are not explicitly initialized or bound, helping define a clear API and ensuring proper property passing without relying on unqualified access. For a deeper understanding of required properties, refer to the Model View Delegates course available on Qt Academy. Use object names. In QML, all object types have access to the objectName property inherited from QObject. This property is incredibly useful for debugging and testing, as it appears in QDebug calls, the debugger inspector, and stack traces. Assigning meaningful object name values to your objects can greatly simplify identification and troubleshooting. Let's see this in action. In the stricter label component, add an object name. Now, when you run the code, the log will show the type of stricter label, its memory address, and the assigned object name. This makes it much easier to identify the specific instance when debugging. This is especially helpful if you're using tools like Squish for testing, as delegates typically don't have unique IDs, making object name a valuable identifier for accessing and interacting with these objects. Be explicit about your colors. When working with value types like colors and fonts, it's important to be explicit in your declarations to avoid misinterpretations. Let's walk through a few examples. First, consider the following property added to a label. This assigns a string, causing bad color var to hold a string instead of an actual color type. A slightly better approach is, here the string red is passed as a parameter to Qt.color, and OKColor var now contains a proper color type. The best approach is to declare the property explicitly as a color. This works because QColor can interpret strings as color values. However, using strings within a var type can still lead to ambiguity, so it's better to use Qt.color red or other Qt QML functions like Qt.rgba when dealing with color values passed through a var. You can also initialize a color by specifying individual properties. Don't use IDs if you don't need them. Not every QML object needs an ID. For instance, when creating styling delegates for Qt quick controls that may be overridden, avoid assigning an ID unless necessary. Let's demonstrate this by customizing the background of stricter label. Now, in the delegate used within the list view, override the background. You can also override it with null to remove it. When we consider the white rectangle, if no ID is provided, the QML compiler ignores it. Execution mechanism ignores it, optimizing runtime by creating only the black rectangle for each delegate. If an ID is assigned, both the white and black rectangles are created, as the white one might have bindings associated with it. The best practice is to avoid assigning IDs to such overridable delegates, ensuring the control remains lightweight and efficient. Use string interpolation. When you want to dynamically insert properties like name, age, and height into a string that updates whenever these properties change, there are several ways to achieve this in QML. First, you might use numbered placeholders and inject their values using .arg chaining. While this method works well, especially for translations where placeholders might need reordering, it can become verbose. Chaining multiple .arg calls can make the code less readable and prone to errors when refactoring or reordering arguments. A simpler yet still basic approach is, this method works but quickly becomes difficult to read as the string gets longer. Additionally, such concatenation doesn't translate well, making it unsuitable for localization. A much more efficient way to handle dynamic strings is to use template literals, which are strings enclosed in backticks. This allows embedded expressions, known as substitutions. It's a powerful feature, and one of the simplest ways to use it is with QML properties. Template literals are more readable, as they use meaningful property names instead of cryptic placeholders. They also eliminate the need for chaining arguments. The entire string is reevaluated whenever any property used within the expression changes. Note: template literals in QML are currently not fully supported for translations, so use them where localization is not a concern. Another advantage is how easily multi-line strings can be represented. Instead of writing, you can simply write. This method is cleaner and easier to manage, especially when dealing with longer multi-line texts.